Okay. We are in permutations. It's day 2 of probability. A permutation is an arrangement of objects in a specific order. So order matters because we're going to have a time where order does not matter. Okay, when objects are arranged in a row, it is called a linear. Think of a line. Linear permutation. So we're going to talk about linear permutations here. It says find all the possible numbers that can be formed using 1, 2, 3 only once. So we have a 1, 2, and a 3, a 1, 3, and a 2, a 2, 1, 3, a 2, 3, 1, a 3, 1, 2, a 3, 2, 1. So that's 6 ways. Just like the tree diagram in your notes from yesterday, this is a long way to do it. You have 3 options for your first number. So if we had a digit, there was 3 options here, a 3, a 2, and a 1. Once you use one of these, we have 2 left. And then 1. You multiply your ways together using the fundamental counting principle, and we have 1, 2, 3, 4, 5, 6 ways. Okay, so that's a permutation. It says find all the possible words that can be formed using A, B, C, D, E. We're calling that a word. Okay, that's a lot. If I were to have a 5-letter word, I could choose A, B, C, D, or E for the first letter. So I have 5 options. You put your option numbers here. If I then use A, then I could use B, C, D, or E. And when I pick one of those, okay, it's descending. So 5 times 4 is 20, and this is 6. So 20 times 6 is 120. Yeah, that'd be a lot to write out. It says, how many different ways can the students line up in class? Well, the order matters. Think about first grade. If you were the line leader, that was a big deal. So order mattered. So say we have 30 students. Okay, I choose a student. Now I have 29 options, and then 28, all the way down to 3, and then 2, and then 1. You could type this in your calculator. You could do 30 times 29 times 28 times, and keep going and going and going. Or you could use what's called a factorial. 30 factorial. Okay, that means that you're taking 30 and multiplying all the descending numbers. So you type 30, you go to stat for statistics, and you go, or is it math? Yeah, hit the math button. I apologize, math button's right there. And then go over to probability, and you go down to the number 4. So it's not 30, or it's not 30 exclamation point, it's 30 factorial. This number's so big, that's like saying 10 to the 32nd, like scientific notation. It's so big. Yeah, we couldn't write that. So down here, we'll write about 2.7 times 10 to the 32nd. Okay, ballpark. All right, so what exactly is a factorial? We said if n is a positive integer, then n factorial is defined as n times, well, what's 1 less than n? N minus 1 times n minus 2 times, because it's 1 less, 2 less, okay, all the way down to 1. The number of permutations given of n objects is considered, this is how many permutations it has, n factorial. How many permutations were there of 30 students? 30 factorial. Okay. So on a baseball team, 9 players are designated as the starting lineup. Before a game, the manager announces the order in which the 9 players will bat. How many different possible orders are there? So if I had 9 players, 1, 2, 3, 4, 5, 6, 7, 8, 9, and this was the order, I'd have 9 to choose from. Okay. And then once I pick a player, I have 8, and then 7, and then 6, and then 5, and then 4, and then 3, and then 2, and then 1. And you multiply your ways together. Okay, or you could say 9 factorial. Or you could say I have 9 players. And R is how many I'm using. And I'm using online players. So I have 9. And then in your calculator, there's a button for this. So you could do 9 factorial. You could do 9 math factorial and get 36,280. 362,280. 362,880. Or you could do 9 probability button and PR for permutations, where N is how many you have and R is how many you're taking. I have 9 and I'm choosing to take 9. You should get the same thing. Yep. Okay, so there's 3 different ways you can do it. Logic, factorial, formula. Example 5, in a competition of 5 students, there is first, second, and third place are awarded. So there's first place, there's second place, and there's third place. How many different possible outcomes are there? Well, I have 5 students that could go for first place. So that's how many options I have for first. That means that there's 4 left for second place and 3 left for third place. I didn't use all the numbers. That's okay. All right. This is using logic. If I have 5 ways and 4 ways and then 3 ways, the fundamental counting principle lets me multiply those ways together. I'm going to get 20 times 3, which is 60 ways. Okay. If we use factorial, we'd say 5 factorial. But I'm not using 5 factorial. I'm missing the 2 and the 1. So however many ways you have, or 5 minus how many you're taking, 3, we have 5 factorial getting rid of the 2 factorial. We don't have 2 and 1. Now, if you're like, this is confusing to me, that's okay. Just focus on this or use the formula 5 NCR, you're taking 3. You will get the same numbers every time because here you're removing that 2 factorial. If you're like, this is confusing, why are we doing it? Because as you get into higher math and as you get into probability and statistics, knowing where these come from will help you immensely. Okay. And this is going to be that. Because, yeah, think about it. This is going to be 5, 4, 3, 2, 1 over 2, 1. It's the same as that. Okay. All right. On the back. Okay. Don't mind this was taking attendance during a Zoom meeting. Okay. It says, find the number of ways to listen to 5 different CDs. Does it matter how you listen to music? Absolutely. Ask a DJ. You don't want to start a wedding off or end the night with a really slow, sad song. Okay, if you're at a wedding, you want to have a great song to finish the night. So order matters when you're listening to CDs. Say there's 5 CDs. You kids are too young to know that there was a 5-disc CD player in cars. I remember a time where if you got a 5-disc CD player in your car, that was cool. Anyway, you have 20 CDs to choose from, and then when you choose one, you have 19 left, and then 18, and then 17, and then 16. That is the same thing as saying I have 20 CDs, order matters, so I'm using permutations, and I'm taking 5. That is the same thing as saying I'm going to use 20 factorial, but I only have 5, so 20 minus 5 is 15 factorial I get rid of. These are all going to be the same. So 20, I'm just going to do this because it's easier, times 19 times 18 times 17 times 16. Some methods will be easier than others in different circumstances. There's over a million ways, okay? So it says to find the permutations if you had n objects and you're taking r, these are all your ways you could do it. N PR is equal to n factorial over n minus r factorial. Okay. We didn't do the spaces because I don't know how many R spaces is. So this is what the formula is. Okay. Now we have trickier examples that don't follow this formula. Say you want to rearrange the letters in Mississippi. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you're going to use all 11 letters. So we could just do 11 factorial. However, I have 4 S's. If I switch these S's around, you're not going to be able to tell which S is which. They're all the same. So that 4, 3, 2, 1 ways or 4 factorial ways needs to disappear. They're not distinct. You need to get rid of them or divide them out. Same with switching all the I's. That 4, 3, 2, 1 ways don't get repeated. I mean, they do get repeated, so they're not distinct. They're not distinct letters. And those 2 P's, if you switch them, it's not going to make a difference. So what you need to do is put this in the calculator with parentheses, because it'll just be 11 factorial divided by 4 factorial unless you use the parentheses. And that would use multiplication. So 11 math probability all the way down to factorial divided by parentheses 4 factorial 4 factorial 2 factorial equals 34650. So there's over 34,000 arrangements that can be made. Okay. It says since there are letters in Mississippi that repeat, they are actually less arrangements than if all the letters were different. To account for identical letters, we can divide by the factorial of the amount of repeats. Okay. All right. So the number of distinct permutations of n objects with identical, you just divide. You know what I mean? Get rid of it. The number of distinct permutations with R1 and R2 objects identical is all the different ones. Okay. So it's just reiterating what I said. All right. It says, suppose you want to arrange strawberries, grapes, cantaloupe, and pineapple on a fruit tray. How many different ways can you arrange the fruit? Well, the fruit tray is circular. So we have strawberries, grapes, cantaloupe, pineapples. Okay. We could just do a bunch of different arrangements, but here's what I want to show you. With a circular arrangement versus a linear arrangement, if I take the tray and turn it, and then grapes are in front of me now, and cantaloupes over here, and strawberries over here, and pineapples up here, is this actually a different order? No. Grapes, cantaloupe, pineapple, strawberries. Okay, we'll say I turn the tray again, and I get strawberries down here, grapes here, cantaloupe, and pineapple. The arrangement isn't any different. Strawberries, grapes, cantaloupe, pineapple. Say I turn the tray again, and I get cantaloupe finally here, pineapple here, strawberries, and grapes. Turning that tray, the arrangements still aren't different. So I have 4 pieces of fruit. I normally would do 4 factorial, but in that 4, 3, 2, 1 way, those 4 options aren't unique. So it ends up being 3 factorial, which is 6. So there's 6 options for the tray. Okay. So anytime you see a tray, the reason why you're going to subtract 1 is because, is it 4 factorial? Subtract 1? No, it's 3 factorial. Okay. People are just like, why would I subtract 1? So that this number goes to the number lower in it, because there's this many ways that are not distinct. Some of this might click for you. It might not. Okay. Some people are like, I'm just going to memorize that you subtract 1. Okay. I don't encourage that, but that's what you have to do. It's what you have to do. Okay. So right here, use permutation or combination to answer each question. This might be another page. Explain why you chose P or C. So you got to tell me if order matters or not. In how many different ways can 8 students be selected to serve on a committee? Well, it didn't say one was the president, one was a vice president, one was a secretary. It just said 8 students on a committee. So it is going to be C. Order doesn't matter in groups. Okay. Find the number at which a president, vice president, and secretary can be chosen. These are distinct positions. Order matters. I need to really explain it. They are distinct positions. Okay. So what you could do is, we're just going to focus on this one, do the combination notes, and then complete it. But permutation is, I have 1, 2, 3. I could do president, vice president, secretary. I could do, and you could figure it out that way, or you could say I have 3 options for the first. I don't have 3 options. I have 10 people. So I have 10 people that could be president. Once I pick one, then I have 9 people to be vice president to choose from, and then 8. This is going to equal 720. Okay, or I could have done 10 factorial, but 10 minus 3 factorial, which is 10 factorial minus, or divided by 7 factorial, which is going to be the same thing. Or I could have done 10 and PR 3. Okay, so that's permutations. Now, here, it says find the number of permutations. This is just more practice. Okay. I'm going to complete this. Do you have to? No. If you'd like to, yes. It says find the number of permutations taking the first 7 letters of the alphabet. So if I have 7 letters and I'm taking all 7 letters, that's what it would be. And you'd put it in your calculator. So I have 7 letters and I'm taking 5. Put in your calculator. I have 7 letters, but I'm taking 4 letters. And I have 7 letters, but I'm taking 3. That's what that means. In how many ways can 12 books be displayed on a shelf? If the given number of books are available. So I have 12 books and I want to use 12 books. There are 14 books, but I just want to use 12. There are 15 books, but I just want to use 12. And there are 20 books, but I just want to use 12. The bigger number will always go here because this is the total amount that you have to choose from. Okay. It says find the number of permutations in the letters of each word. Geometry. There is 1, 2, 3, 4, 5, 6, 7, 8 letters, and I'm going to use all 8. However, the E's can switch so they're not distinct. Algebra, 1, 2, 3, 4, 5, 6, 7 letters, and I'm going to use them all. Okay. You can put 7 factorial here, or you could have done 7 NPR 7. It doesn't matter. The A's can switch. Addition, 1, 2, 3, 4, 5, 6, 7, 8. The D's can switch, and so can the I's. Make sure you use parentheses, okay? So that's how you do those. Here it says, Lizette decorates for a window department store. She has planned to design a baby's room. 8 elephants, she has elephants and monkeys. If she has 8 identical elephants and 10 identical monkeys, how many different ways can she use this with animals? Okay. With a row of stuffed animals and monkeys. Okay, so she has. What did I put? I don't want to tell you something wrong. How I notated it. Here, and I'll also give you the answers. So these are the answers for the top part. You pause it. And then this is the answer for the bottom part. So, okay, I did put it 2 ways. So here you could write, I have 18 total, but remove the 8, remove the 10. Okay. Oh, that's for the next one. So you can just write it like this and you get 43,000. For the next one, it says 6 candidates for student government and you're choosing 6. So either one would have worked. You have a circular table with 8 schools, so 8 minus 1 factorial because it said circular. And here, 10 and 10, so either one would have worked. Okay, now on this page, day 3, we're going to do combinations. Okay, so watch the next video for that one.